Good evening, sir. My name is Shreyas. Today, in this presentation, I'm going to explain about Nand To Tetris. Coming to the components of this presentation, we are going to learn about Nand To Tetris, benefits of Nand To Tetris, and the learnings in the Nand To Tetris, tools and resources used in this project, and the hardware and the software tools required for this project. Coming to the introduction of Nand To Tetris. This is a project-based course called Nand To Tetris, teaches students how to construct a computer from the ground up. Beginning with the fundamentals of Boolean logic, it progresses to building a complete computer with an assembler, a compiler, and an operating system. Students completing this course will have a thorough grasp of software engineering and the computer architecture. The Nando Tetris course is structured into two sections. The first section concentrates on the hardware aspect of creating a computer, and the second section addresses the software aspect. Additionally, they'll also learn how to build and install a virtual machine and create a high-level programming language and write programs in the assembly code. Now moving on to Revelation, a thorough and a practical method to understanding computer architecture and software engineering is provided through this course. It teaches students how to construct a computer from the ground up and provides them with a grasp of how computers operate inside and out. Students will receive important knowledge and abilities by finishing this course, and this will aid them in their future jobs. Students also have the chance to collaborate and think critically while taking the NATO Tetris course. By working together on the projects, students will learn how to solve problems and think creatively. They will also gain problem solving and critical thinking abilities, which are crucial for any employment in the IT sector. The learnings in this courses are: students will be learning the fundamentals of Boolean logic as well as how to design and construct logic circuits in the NATO Tetris. Furthermore, they will learn how to develop programs in assembly code and create a high-level programming language. Finally, students are going to discover how to design, construct, and build an operating system for a virtual machine. At the end of this course, students will have a thorough grasp of computer architecture and the software engineering, as well as the abilities required to design a fully functional computer from the ground up. Moving on to the tools and resources required for this course. This course delivers students with the skills and resources they need to successfully complete their assignments. This program comprises of an assembler, a compiler, and an operating system, which will be made available to the students. This will also be handled through the hardware simulator, which will let them how to do the projects and all. Furthermore, the course offers students a full set of notes and assignments and will assist in comprehending the ideas and completing the task. Before starting with this NATO Tetris hardware simulator, students should ensure that they have the proper hardware and software before beginning this course. They will have to require a PC with the NATO Tetris program and NATO Tetris hardware simulator installed. They should also ensure that they have a fundamental comprehension of the Boolean logic. Hardware building in NATO Tetris. The hardware development portion of NATO Tetris project comprises building a simple computer system out of basic logic gates and other electrical components. Building logic gates. The first stage in the creation of a computer system is the construction of fundamental logic gates such as NAND gates and NOT gates. Electronic components like as transistors, resistors, and capacitors can be utilized to generate these gates. Testing and debugging. After the hardware has been built and connected, the computer must be written. This may be done using either a basic assembly language or a higher level language using the assembly level coding. Designing a circuit board. Once each component has been built, a circuit must be designed to connect them. This may be accomplished using either a special design circuit board or a breadboard. Mostly we'll be using breadboard itself. The circuit board should be designed with the least amount of wire and appropriate connections for each component in the mind. Getting over the software tools, the Nando Tetris project includes creating a straightforward computer system from scratch, beginning with the elementary logic gates and ending with a machine that can execute programs. Throughout this project, many software tools are employed to help this process. There are a few main software applications used in this project, such as hardware description language, also known as HDL language or HDL code. This is a programming language called HDL used to define how electrical circuits behave. HDL is used in the Nand to Tetris project to define the behavior of more complicated parts like adders, registers, and CPUs, as well as more fundamental logic gates. Text editor. The HDL code, the assembly code, and the other programming files are written and edited using the text editor, which will be normally available in the basic PC. Hardware simulator. To verify the HDL code and replicate the operation of the electrical circuits, a hardware simulator is employed. This enables you to evaluate the functionality of the circuits without having to actually implement them in the hardware. Assembler. An assembler converts assembly code, which is a low-level programming language, into the machine code, binary code that can be executed by only computer and which can be understood by the computer itself. In the Nand to Tetris project, an assembler is utilized to convert assembly code into machine code that can be run on a computer. Virtual machine. A virtual machine is used to mimic the behavior of a computer system. By executing the machine code and doing tests, you may evaluate the operation of the computer system without actually manufacturing the physical hardware. Operating system. As part of this project, a minimal operating system is constructed from the scratch. Now coming over to the project, we will be given a NAND gate, and our main goal is to uh, evaluate the NOT gate, AND gate, OR gate, XOR, and rest all etc. gates which are being visible here in this presentation. And we'll be doing this. We're doing two types of simulation, which are interactive based simulation and the script based simulation. There's a third simulation which is with or without compare files, which we'll be doing later in this project course. Now moving on to the hardware simulator. As you can see, this is a hardware simulator. And there are three boxes here, which is input pins, output pins, and the HDL code. Here we'll be loading our HDL code in this section, and the output will be giving here in the view section. So let's start with the AND gate. Now click on this load chip icon and load the and.hdl file. You can see that here the code is visible, which is this AND gate code is written here with the chip and input of A and B, and the parts which are given as a NAND gate. Here in the input pins, you can see the variable names A and B and the values such as 0 and 0. As we know that in the NAND gate, the value, if we given 1 and the other one is a 0, the output will always be 0. So now let's click on the calc evaluation icon and you can see the value is 0 here. Now let's change the values and let's check for the output. Now let's give B as 1 and then click on the evaluate option. And you can see that in the output, the value is changed to 1 here. So now, as you can see, the value of output is 1 here. So this is an interactive based simulation where we can verify the truth table of the many gates here. Now moving on to script based evaluation, click on the load script icon here and then click on and.test file. As you can see, the script is also loaded in this section and you can evaluate this either in a whole process together all together or in a step-by-step process. Now let's head on to the step-by-step process so that we'll be able to check all the outputs for A as 0, B0, A0, B1, A1, B0, A1 and B1. Now let's click on this single step evaluation icon and it moves on to the set A as 0 and set B0. So the output value must be 0 for 0 and 0 in the NAND gate. Moving on to the next set of values, it is 0 and 1. You can see the output value is still 0. Moving on to 1 and 0, output value is still 0. Moving on to 1 and 1, you can see that the value of output is changed to 1 here. To view the whole truth table, just go to the view here and just click on output. After clicking on the output, you'll be able to see the value of A and B and the outputs with the various values inputted with the A and B. This is the script based evaluation, which is giving us the output based on the script. Now let's evaluate this for other gates. For example, let's take an OR gate here and the load chip. Let's give a value of 1 to A and 0 to B. So we know that our output must be 1 for value of A0 and B1 in an OR gate. Let's evaluate and check it. Yeah, it is correct. It is verified that the output is 1. So, and the code is also correct, which is including the NAND gate, which we basically given at the starting of the project. Now let's go to script-based evaluation. Now search for all.txt file and just click on load script. The script is loaded here, and let's go for checking individual values inputted for A and B. Moving on to 0 and 0, we'll be getting the output as 0 here. And now moving on to 0 and 1 input, that will be getting the output as 1 here. And moving on to the 1 and 0 input, still the output is 1. And 1 and 1 input will be getting the output as 1. View the truth table of OR gate, click on view and go to output. You'll be getting your whole truth table here. Like in this manner, we can do for either DMUX 4-way. As you can see, many HCL codes are available here. You can evaluate in the same way. And these are the outputs for AND gate, OR gate, NOT gate, XOR gate, MUX 4-way, which is already given the interactive based output and the script based output, including the truth table provided here in the picture. MUX 8-way, MUX 16, DMUX 4-way, DMUX 8-way, and 16 or gate 16, or gate doing it the 8-way, not 16. Coming to the end of this presentation, the conclusion. Students may study computer architecture and software engineering by taking this course. It provides us a thorough and a hands-on approach to learning and allows students to collaborate and think critically. By the end of this course, students will have acquired the knowledge and abilities required to construct a computer from the ground up. This course is a wonderful place to start if you're interested in understanding computer architecture and software engineering. You can even construct a completely functional computer from the ground up if you have the necessary tools and the resources. Thank you.